Find the maximum moment in beam AB. In this problem, a 48-foot long beam AB is connected with a pin to a vertical wall at joint A and with a roller to a flat surface at joint B. At distances of 12 feet, 24 feet, 36 feet, and 48 feet away from joint A, a downward point force of 800 pounds is applied to the beam. To find the maximum moment in the beam, it may be easiest to sketch out the shear and moment diagrams in the beam. To sketch the shear diagram, we first need to determine the vertical reaction forces at joints A and B. By summing the moments about joint A and setting the value equal to 0, the vertical reaction force at joint B equals 2.5 times P, or 2,000 pounds. The vertical reaction force at joint A can be determined by summing the forces in the vertical direction, setting the value equal to 0, and then solving for the vertical reaction at joint A, which is the sum of the loads minus the vertical reaction force at joint B, or 1,200 pounds. We'll begin sketching the shear diagram from joint A and work our way over towards joint B. Since the vertical reaction force at joint A equals 1,200 pounds, the shear in the beam just right of joint A equals 1,200 pounds. And the shear along beam AB remains 1,200 pounds until 12 feet in the direction of B, where the point force of 800 pounds acts downward on the beam. For convenience sake, we'll label the three intermediate points C, D, and E. So between points C and D, the shear in the beam equals the shear in the beam from A to C, 1,200 pounds, plus the point load, P, of negative 800 pounds, which equals 400 pounds. Similarly, the shear force between points D and E equals the shear force between C and D, 400 pounds, plus the point load, P, of negative 800 pounds, which equals negative 400 pounds. Lastly, the shear between point E and joint B equals negative 1,200 pounds. Since the problem asks to find the maximum moment in beam AB, we can use the shear diagram to construct the moment bending diagram and identify the maximum moment. Since the shear in the beam is equal to the change in moment along the length of the beam, then the moment is equal to the shear times the length along the beam. Since there is no moment in the beam at the pin connection at point A, the moment at point A equals 0. Since the shear is constant between joint A and point C, the moment at point C can be calculated as the moment at joint A plus the integral of the shear force in the beam over the length of the beam from A to C. The moment at point C equals 14,400 pounds-feet. The moment at point D can be calculated the same way, by adding the moment at point C to the integral of the shear force in the beam times the length of the beam from C to D. The moment at point D equals 19,200 pounds-feet. The moment at point E and joint B are calculated the same way and equal 14,400 pounds-feet and 0 pounds-feet, respectively. The question asks to find the maximum moment in beam AB. This occurs at point D and equals 19,200 pounds-feet. When reviewing the possible solutions, the answer is D.